Hello, here is my video for quality improvement in maths education project 2019. Topic of presentation is trigonometry. This video is developed and presenting to you by Muhammad Abdul Wadud, Assistant Teacher, Noble High School, Labor Colony, Nanded, Maharashtra. My registration number is MTF079. I am Master's Trainer for Quality Improvement in Maths Education. Master's Teachers Training organized by QIME, MSCERT, RMSA and IIT Bombay under the guidance of Professor I. K. Rana, IIT Bombay and Professor S. T. Gharpure, IIT Bombay.
Basic trigonometry. Observe and explore. Dear students, do you have any idea how will you find the height of mountain or the distance of a ship from the bank of sea or the height of an aeroplane which is flying? Think it carefully and tell me. These all questions are answered with the study of trigonometry. Dear students, today we are going to learn a new chapter, trigonometry. As you all know already about right angle triangle, now we will revise it. Hypotenuse. In a right angle triangle, the side opposite to 90 degree is an hypotenuse. In figure, AC is hypotenuse. In this figure, the opposite side of angle A is BC and the opposite side of angle C is AB and the adjacent side of angle A is side AB and the adjacent side of angle C is side BC. Now we learn all the ratios which are essential. The first ratio is sine opposite side upon hypotenuse, and the second ratio is cos adjacent side upon hypotenuse, whereas the third ratio is tan opposite side upon adjacent side. There are some inverse ratios. Opposite of tan is cot adjacent side upon opposite side, whereas the inverse of cos ratio is sec hypotenuse upon adjacent side. Also, the inverse of sine ratio is cosec, that is hypotenuse upon opposite side. Now observe carefully. Here the inverse of sine function is cosec, that is opposite side upon hypotenuse. This ratio is sine ratio, whereas the hypotenuse upon opposite side is cosec ratio. Therefore, here we can write it as sine A is equal to 1 upon cosec A, or cosec A is equal to 1 upon sine A, or we can write it as sine A into cosec A is equal to 1. Let me ask you again. What is the reciprocal of sine A? Dear students, the reciprocal or the inverse of sine A is cosec A. You understand? The inverse of sine A is cosec A. Also, we can write it as cosec A is equal to 1 upon sine A, because as sine A is the inverse of cosec A, cosec A is also the inverse of sine A. Therefore, we can write it as sine A is equal to 1 upon cosec A. Also, we can write cosec A is equal to 1 upon sine A. You understand? Now conclude here that sine A and cosec A are inverse of each other. That's why we can write here sine A into cosec A is equal to 1. You observe it. Whenever the two functions or the two ratios are the reciprocal of each other, their multiplication or their product is 1.
Evaluation.
Now we will solve example. If sine A is equal to 3 by 5, then find the value of cosec A. Answer. Given sine A is equal to 3 by 5, but we know that sine A is equal to 1 upon cosec A. Therefore, cosec A is equal to 5 by 3. Remember, as sine A is 3 by 5, we know sine A is the reciprocal of cosec A and cosec A is the reciprocal of sine A. Therefore, cosec A is equal to 5 by 3. Similarly, cos is the ratio of adjacent side upon hypotenuse. Its inverse is sec hypotenuse upon adjacent side. Therefore, we can write it as cos A is equal to 1 upon sec A and sec A is equal to 1 upon cos A. Therefore, we can write cos A into sec A is equal to 1. So, adjacent side upon hypotenuse is the ratio of cos and its inverse is hypotenuse upon adjacent side, that is the ratio of sec. So, we can write cos A is equal to 1 upon sec A, because cos A is the reciprocal of sec A. Hence, we can write sec A is equal to 1 upon cos A. That's why we can write cos A into sec A is equal to 1. So, we can conclude now, when the two ratios which are reciprocal of each other, their product is 1. That's why cos A into sec A is equal to 1. Now, if sec A is equal to 5 by 4, find cos A. Answer. Given that sec A is equal to 5 by 4, we have sec A is equal to 1 upon cos A. Therefore, the value of cos A is 4 by 5, as sec A is 5 by 4. Therefore, the reciprocal of sec A is cos A. Hence, cos A is equal to 4 by 5. Tan is the ratio of opposite side upon adjacent side, whereas cot is the ratio of adjacent side upon opposite side. Therefore, tan A is equal to 1 upon cot A, or we can write it as cot A is equal to 1 upon tan A. Hence, we can write tan A into cot A is equal to 1. Dear students, as you know very well, sine is the reciprocal of cosec and cosec is the inverse of sine. Therefore, we can write it as sine A is equal to 1 upon cosec A. Also, cosec A is equal to 1 upon sine A, and sine A into cosec A is equal to 1. Similarly, cos is the reciprocal of sec A and sec is the reciprocal of cos. So, we can write cos A is equal to 1 upon sec A, or sec A is equal to 1 upon cos A. Also, cos A into sec A is equal to 1. So, in the same way, we can tell about tan A and cot A, as tan A is the inverse of cot A and cot A is the inverse of tan A. That's why the product of tan A and cot A is 1. You have to remember these all three pairs of trigonometric ratios. So here we can write tan A is equal to 1 upon cot A, or cot A is equal to 1 upon tan A, because tan A is the inverse function of cot A and cot A is the inverse function of tan A. That's why tan A into cot A is equal to 1. Define and prove. Prove that sin A upon cos A is equal to tan A. Proof. From the figure, we can write sin A is equal to BC upon AC, as we know sin A opposite side upon hypotenuse. Therefore, here sin A is equal to BC upon AC. Similarly, we know that cos A adjacent side upon hypotenuse. Therefore, we can write it as cos A is equal to AB upon AC. And similarly, tan A is equal to opposite side upon adjacent side. Therefore, here from figure we can write tan A is equal to BC upon AB. So, by keeping the values of sin A and cos A in the left hand side, that is sin A upon cos A, that is in the numerator, the value of sin A we put BC upon AC, and in denominator the value of cos A as AB upon AC. Therefore, AC get cancels and we remain with BC upon AB, that is the value of tan A. Hence, left hand side is equal to right hand side. Hence the proof. Now remember, sin A upon cos A is equal to tan A, and cos A upon sin A is equal to cot A. Also, you have to remember that sin square A plus cos square A is equal to 1, and second, tan square A plus 1 is equal to sec square A. Also, third, cot square A plus 1 is equal to cosec square A. Dear students, these three basic identities are very essential for solving the problems on trigonometric functions, which are sin square A plus cos square A is equal to 1. You have to remember these three identities. Second one is tan square A plus 1 is equal to sec square A. Also, cot square A plus 1 is equal to cosec square A. Now we prove these three identities one by one. First we prove sin square A plus cos square A is equal to 1. To prove sin square A plus cos square A is equal to 1, we will use Pythagoras theorem. First, we will find from the right angle triangle the values of sin A and cos A. As you know from figure, sin A is equal to BC upon AC and cos A is equal to AB upon AC. Therefore, in triangle ABC, by Pythagoras theorem, AB square plus BC square is equal to AC square. Now divide this equation by AC square to both sides. Then we get here AB upon AC whole square plus BC upon AC whole square is equal to AC upon AC whole square. Therefore, here AC get cancelled and we get cos square A plus sin square A is equal to 1. That is, sin square A plus cos square A is equal to 1. To prove tan square A plus 1 is equal to sec square A, we have to divide the Pythagoras theorem, that is BC square plus AB square is equal to AC square by AB square. Therefore, BC by AB whole square plus AB by AB whole square is equal to AC by AB whole square. So here AB get cancelled, and from figure we get BC upon AB as tan A and AC upon AB is sec A. Therefore, we remain with tan square A plus 1 is equal to sec square A. And if we divide the equation of Pythagoras theorem by BC square, then we will get cot square A plus 1 is equal to cosec square A. Now remember some more identities. Number 1, sin 90 minus theta is equal to cos theta. Number 2, cos 90 minus theta is equal to sin theta. Number 3, tan 90 minus theta is equal to cot theta, and cot 90 minus theta is equal to tan theta. Number 5, sec 90 minus theta is equal to cosec theta, and number 6, cosec 90 minus theta is equal to sec theta. Now we will see the proof and the uses of these identities in the next video. Thank you.